Hey everybody, this is Larry. This is me going to do the daily problem, day 16 of the, what month is this? June daily challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about this problem. And it's a hard one today, so sorry that I didn't do it earlier. I just got back from a way long trip. Still at Almaty here in Kazakhstan. So yeah. But anyway, let's take a look. Number of ways to reorder array to get the same binary search tree. Okay. So no drone today because I'm too tired. Well, I'll get some back. So definitely hit that button and go with the IG and all this stuff. Yeah. Am I on the right tab? Oh no. Oh, I had the wrong tab then. That's why I was checking. Give me a second. Okay, let me just close out the other tab then. Wow, lucky I caught that one a little bit earlier. I was like, something's a little bit off. Okay, sorry friends for technical difficulties. We'll be right back. And I just wrote the mod stuff because, you know, mod are. Okay, so we have 2 as the root, 2, 3, 1 also use the same binary search tree. Oh, is this the insertion order? Okay, so yeah, I'm checking the n, and n is 1,000, so we could do an n square type algorithm. Let's see, right? So what are we given? We're given a list of numbers. So 2, 1, 3. What does that mean? That means that the node that we have now, the tree will look like this, right? So the question is, so here the thing that you're trying to do is, well, one is the n is 1,000, so it's probably dynamic programming. It's just a guess, to be honest. And then the second thing is I'm trying to figure out an invariant that we can reconstruct this recursively, right? So there are really two. Yeah. Oh, this is a hard one. I don't know. I don't have an answer right off the bat, to be honest. So let's say you have 2, right? And then what happens? And then now 2 is the root of the tree, right? And then now what is the recursion here? All the numbers in order on the left and all the numbers in the right are interleaving into the same way, right? So basically all the orders that are bigger than 2 have to have the same order, and all the numbers bigger than or smaller than 2 has the same order as well, and then it's just interleaving them. And I'm checking the distinct thing because I was checking to see, because that was the only thing that could go wrong, right? So that means that the same thing for example 2 is that if we have 3, then yeah, if you look at these, this is just an interleaving of 1 and 1, 2, the left side, and then the right side, because that has to be the same. And okay, I mean, so that's fine. And then now, and then it's recursive, right? Meaning the number of times to do the left and then the number of times to do the right. So then now in this case, for example, we have something like this, then this is just the number of left, or sorry, that's the number of right, oops, right? And then left is equal to 1, 2. And then now the recursion is how many ways are there, right? Because then the number of ways, and then how many ways are there to interleave them? How many ways are there to interleave them? I feel like that should be a easy thing, but maybe not. I mean, this part is just recursion. So once my computer is, or at least my browser, I don't know, maybe even my OBS. my computer's frozen up. I don't know if this is recording or you could hear me or whatever. But basically the idea is that my computer's crashing. I don't know if this is recording. What am I doing? Why is this happening? Oh, there, now it's back. Okay, sorry friends. I was just, what happened here? Hopefully this is recording. If not, then my apologies. But okay, so yeah, so recursively go, okay, the numbers of the numbers that are bigger and the numbers of and then just do recursion, right? That part is okay. But what is the interleaving, right? Meaning that you have, okay, xx, xxxx, so you have 5 x's. And then now you want to do 4 of them or 3 of them, right? And I guess in this way, it is just n, or in this case, if you have, so this is just, should be left plus right, choose left or something like this. Maybe just plus 1. Or, something like this is not quite this. Let me think about this for a second, right? Because the idea is that, okay, you have right plus 1 spaces in between the things, right? So you have 5 x's, there should be 5 of them. And then you want to choose 3 of them, or sorry, left of them, right? And that should be good. Yeah. Because in this case, it's not that the items are interchangeable. It's that you have no choice in the ordering, so it's kind of like irreplaceable, right? So this is just combinatoric stuff, and that should give us the answer. Yeah, I think that's it. I mean, we have to be careful about mods and stuff like this, but I think that's basically the core idea about solving this problem. Yeah, I mean, this is kind of a tricky one, so let's get started then. So okay, so then here, let's say count, right, of an array, right? Let me just go R, right? So then now you have left is equal to right is equal to right? So so for x in array, left, if x is, we want r sub 0, right? So current is equal to this number or the root or node or whatever. And then here we can just do from the first item on. And then if x is greater than current, then we put it to the right. Otherwise, we put it to the left, right? And then now left count is equal to count of left. Right count is equal to count of right. And then in theory, I mean, we have to do some, I thought it was going to be dynamic programming, I was wrong. But it is still n squared because of you know, the summation of from 1 to n type thing. But still, yeah. And then here, maybe the bigger is equal to max of left count, right count, and smaller is equal to min of this. I don't know if this is the cleanest way to write it, but that's what I'm going with for today, right? And then it is bigger, choose 1. Yeah. And of course, you have to do this in a mod-friendly way, right? So this is part where you could do it with dynamic programming, which I would do. So yeah, so return I don't know, comp of bigger plus 1, smaller maybe. And hopefully this is right, because you know, maybe I don't know yet, right? I think, I mean, the complexity and stuff should line up. So just to, yeah, let's say this is all 1 because we amortize it to DP, dynamic programming. Then the count, this should be n squared because you can imagine that we just, let's say you have an ordered list, then you just keep on taking 1 off the list, and that's going to be n squared, right? Sorry, getting weird messages. Okay, so yeah, so then now now was it R and C? R and C, and choose C. I forget the notation. And choose R, maybe? I don't know. I don't remember the notation. And of course, that is, if you remember your binomial distributions, it's just, n minus 1 or plus n minus 1 or minus 1, I think. Maybe I messed that up. That'd be funny. Let me just cache this real quick. Usually I do the thing about DP, but clearly I'm not doing it here. Oh yeah. If length of R is equal to 0, return 1. I forgot the base case. Oh, I also forgot the base case here. So yeah, if is this right? Because this then R can be bigger than n, right? Right? Or did I mess this up? Huh. I usually write it a different way, but today I'm tired. Yeah. Maybe just something like this. Alright. Alright, well, this is way wrong. I think my combinatoric is wrong. Let me, but I want to, I mean, this is a thing, but it doesn't mod, right? That's why this is wrong. But I just want to test this part, that's why, before I do it. I mean, that wasn't going to fix it, but okay, so 2, 1, oh, I did know that we had to minus 1 because we also count the original one, so yeah. But here, let's see, right? Let's see, maybe I'm off by a little bit. Let's double check. I think the idea is okay, but maybe not. So then here you have 1 and 1, right? So then you have 2, choose 1, right? So you have 1, 3, and then 3, 1. So then this should return 2, right? How did I get 3? Oh, with length of 0, it is 1. Maybe I mixed this up. Did I get it wrong? I don't think so. I mean, maybe it's off by something, but I don't think that is wrong. Maybe the base case is wrong. If it's 0, then it should return 1. Right? If there's no element, if there's no element, no, we should return 0. No, still, oh, then now I can maybe do the minus 1 thing. Okay, so this is still wrong, but this is hard to try to rush through. I think the concept is mostly right, but maybe not. 3, 4, 5. So here you have 2, 2. So as we said, so then now we have 6 ways, right? Because this is 3, choose 2. We have 2, 2, 2 items, 3, 2. Maybe I did. Oh, I'm wrong. This is wrong. Okay. Because I assumed that if we have y, then it would just be y and y. But actually, you can have this as a combination. I just messed up. What is the end? Man, I don't. This is not combinatorial, maybe. Or not in this way. Really bad. Is it just multiply? Maybe I just confused the way to do it. Like we just return. Today my math brain is shot. Like, does this work? Maybe not. Oh, this shouldn't be returning 0 then. Why is that returning 0? Oh, because this is always just returning 1 and 1. Sorry, yeah, how do we, how do I do this? So I guess this is just, okay, so for each of y, we can put it in, no, but it has to be in order, right? So we can, the order, oh, how do I feel in this part? The other part is fine, but how do I do the math? Okay, so this is wrong, I think. This is why I kind of did this here, so that I don't have to, in case this is wrong, and it is. So, okay, so if this, how many ways are there to do interleaving? Maybe I don't know. Okay, I mean, we could do this recursively, right? So f of 2 is equal to, okay, we take one from the x, or we take one of the, right? And then f of 1, 2, which is then now, again, is equal to, right? Or plus f of 1, 1. I mean, I guess we could just write this, right? It's fine. So here, then now, maybe I don't have to solve for it in my head. We can just write this, right? So then now we maybe write f count of left count, right count, right? And then this is just the recurrence, right? So f count of left, right, right? I'm going to skip the caching explanation for today. Usually I go over memorization and how it works a little bit at least. But if you're under this problem, then we're just going to skip that for today. Yeah, and then as we said, what we want is if left is equal to 0, then we return 1. If right is equal to 0, we also return 1 because that means there's only one way left. Otherwise, we can just return f count of left minus 1, right, plus f count left, right minus 1, and we want to mod this. Why? Tell me why. How wrong am I? I'm very wrong. Alright, maybe this one is instructive because it's giving me 3. Maybe we go just print it out instead of trying to figure out what it's doing. So okay, so one for number, if the array is 1, oh. Now is this thing, so this thing is not quite right. This is should be length of left, length of right to do the number of interleaving, and then you times this by left count times right count for the number of combinations, I think. I don't know why I didn't think it through. I'm going to just submit it real quick, and then if it's right, then I'll explain it, because if it's wrong, then, you know, maybe it's too slow. Okay. That was tough, as you know. I mean, maybe a little bit slower on this side. But yeah, so basically F count, like we said, is that we just, you have a list of length, and instead of trying, I did try to figure out the formula for a while, but instead I was just like, okay, let's just, I mean, and maybe the people who are eagle-eyed or maybe have a better memory than I do, maybe they recognize this. It feels very familiar, but today I am having an off day. But when you're able to do stuff with an off day, that's not so bad, right? But yeah, but for this part, this is basically the number of interleaving, right? And then left count is the number of ways to, or number of orderings from the left side and number of orderings from the right side. And then you kind of multiply them, because that's the number of ways that you can construct that in that order, right? So that's basically the idea. What's the complexity? Like we said, this is going to be n squared just because of the way that this is constructed. This is also n squared, but it's also amortized, right? So just n squared plus n squared. So this is going to be n squared in total time. And in space, same thing, because of at least how we did the array thing. And I don't know, that almost like a pivot type thing, right? So and I don't know if you could do it a little bit better than that, but yeah. I'm really tired. Sorry, friends. That's all I have for this one. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later, and take care. Bye-bye.